Today is the 26th day of the LeetCode 30-day challenge, and the problem is longest common subsequence. And obviously, this is a very classic dynamic programming problem, so I think there is no need for explanation of this problem. So I will just directly dive into the solution, and I will have some follow-up for this problem because if we just need to solve the length, then it is too easy. Okay, so first initialize the DP array as 0. And then initialize the result and get the length of each string. Okay, so we're not doing the DP part. Okay, so we understand that if the current character is the same, then we can extend the length of longest longest common subsequence by 1. So if current character is the same, then dpij equals to dpi minus 1 j minus 1 plus 1. And else if the current character is not the same, okay, if the current character is not the same, then what we should do, because the current character is not the same, so we can query whether the longest common sequence of exclude this character in string 2 and in string 1 of the current character now, or we can choose from the exclude the current character and the string from 0 to current character, and we either choose the LCS of those corresponding to group for the answer. And there is more detailed explanation in Geek for Geeks. So if there is anything not clear in this video, you can just go to search Google for more information. And simply return dp len1, len2. Okay, and now because we just get the length of the longest common subsequence, now we can try to reconstruct the longest common subsequence. So how do we do that? Simply because now at the very end of the DP table, now where the row is at len1 and the column is at len2, and index of the longest common subsequence will be at their length, corresponding length minus 1. So we can simply use a while loop to build the longest common subsequence, or say reconstruct the longest common subsequence. String LCS is initialized as nothing and that resize. So what we need to resize? We need to resize the result, which is dp then 1 and dp then 2 and dp then 1 then 2. So while I is greater than or equal to 1 and j is greater than or equal to 1. So if si1 minus 1 equals to s2 I minus j minus 1, then this means current is the same, so we can concatenate the LCS. Okay, so LCS dx minus minus equals to s1 I minus 1, and since their ij meets the criteria that the current character is equal, so we can simply I minus minus j minus minus, because we need to shrink the problem size, else if, and otherwise we just check how do we meet this dp element, because every dp element has some ways to reach it. So at here, this means the longest common subsequence that from 0 to I minus 1 index of the string 1 is longer than the longest common subsequence that from 0 to index j minus 1 in string 2, and the situation is they have no common characters, so we need to solve the subproblem that the already solved common subsequence length and get the longer one. So now this comes from I, so I minus minus, and this comes from j, so j minus minus. Nothing too special. And we can simply see out LCS. Let's see if this is correct. I have an example here at these two strings, string 1, string 2. Then the LCS is SDKHSD for the longest common subsequence. SDKHV, SDFJ. And SADKJ, HB, SDKH, SDKJ, HB, SDKH, SDKHSD, SDKHSD. So this is how we reconstruct the longest common subsequence code in this range. And then there is still another follow-up of this problem, which is the print all longest common subsequence in lexicographic order. And this one is quite tough, and you should use the recursion function to solve it. So there are too much to talk about, so I suggest you check the site named Jigs for Geeks for this variation. Okay, let's wrap up for today's problem, and thank you for watching.